Yes, students, today we are doing the motion in plane. Basically, we will be discussing about the projectile motion in detail. And the motion in plane, you all know we are talking about motion in two dimensions. It means it can be xy plane, it can be yz plane, it can be zx plane. Two coordinates are required to specify the motion of the body. Just to revise the things, position and displacement vectors, if I am talking about, this is arm xy plane, this is point position P, the coordinates for P will be xy. So if I draw the projections on the x-axis, on the y-axis, I am getting this length from O on the x-axis for this point of the projection, and if I say this is equals to x. Similarly, projection of the y-axis, this length I am taking it as small y. So if I want to write the position vector r, of course position vector we get by joining the position at a particular instant of time with the origin. So OP, which is written as r vector, it is the position vector at any instant of time when the particle is here at P position. So I can write it in the component form, rectangular components of this x and y. I can write r vector, your position vector is x I cap I j cap. Similarly, if I want to write the displacement vector, then I am moving from P to P dash. It means I am moving from x y position to x dash y dash position. Then what it is, then I have to take the displacement vector, which I can find by using the triangle law. Here if I am joining O to P, I am getting one vector, that is r vector. If I am joining O to P dash, I am getting another vector, that is r dash vector. Then you see the direction. If I am moving from P to P dash, this is the direction. It means direction of OP and P dash, they are in the same order. So R plus delta R, that is equals to the third line, which is the closing side of the triangle, that is R dash. So you can get that R plus delta R, it is equals to R dash, or I can write delta R, it is equals to R dash minus R vector, which is the displacement vector. Now again, if I want to write this in the component form, then of course the value for r dash, it is equals to x dash I cap plus y dash j cap, while for r it is equals to x I cap plus y j cap. So x dash minus x can be written as delta x, y dash minus y can be written as delta y. So I can write delta r, the displacement vector is delta x I cap plus delta y j cap. So this is very important. You should be able to write any vector in its component form, because if you are able to write in the component form, then only we will be able to deal with the motion in plane in more detail. So the knowledge of vectors, resolution of vectors is a must with you for dealing with this study. If you wish, you can write the velocity also in the component form, because velocity is what? Velocity is delta r by delta t, rate of change of displacement. So delta r can be written as delta x I cap plus delta y j cap divided by the time. So I can write it as delta x upon delta t I cap plus delta y upon delta t j cap, or I can write v. If I am writing the average velocity, it is Vx average I cap plus Vy average j cap, because delta x upon delta t is equals to velocity along the x-axis. Similarly, delta y upon delta t is the velocity along the y-axis. Similarly, if you wish to write the instantaneous velocity, again you can write in terms of the limit delta t tends to 0, that is delta r by delta t. And so you can write it in terms of dr, and again if you wish you can write it in terms of components, because delta r by delta t is delta x by delta t into I cap plus delta y by delta t into j cap, or simply I can write v at any instant, that is the instantaneous velocity is Vx I cap plus Vy j cap. So this is important when I am talking about the motion. then I should be able to write velocity in the component form. So at this minute, at P position, if I draw a tangent at that point, that is giving me velocity at that instant. So if I'm resolving it into components, I'm getting the vertical component as Vy, horizontal component as Vx if this angle is theta. Then it means Vx is what? Vx is V cos theta and Vy is V sin theta. So you can write the value of tan theta, which will be equals to Vy upon Vx. From there you can take the direction of the instantaneous velocity. And of course, if you want to write the magnitude, it will be given by simply square root of Vx square plus Vy square. So this is the magnitude of the velocity at any instant, and this is giving me the direction. So these both the formulas are important to study further motion in plane. Though we have discussed all these things in the previous lectures also. So instantaneous velocity, velocity at any instant, but I should be able to write in the component form. It means I will be taking the projection on the y-axis, projection along the x-axis. Similarly, if you wish to write acceleration, that is average acceleration, that is delta v by delta t. So now I will be writing velocity in component form as Vx I cap plus Vy j cap divided by t. So I can write it as Ax I cap plus Ay j cap. And if I am writing the instantaneous acceleration, again it can be written as dv by dt or limit delta t tends to 0 delta v by delta t. So I can write it as Ax I cap plus Ay j cap, and the magnitude is given by square root of the sum of the squares, that is Ax square plus Ay square. And similarly, as for the velocity we have found, we can find the direction for the acceleration also. Simply by using the triangle, you can find the values Ay upon Ax. Tan theta is Ay upon Ax. So this is again, it means by the knowledge of the position vector, I can write the displacement vector, velocity vector, acceleration vector, all in the same group. And if I want to take about the motion with constant acceleration, as you have done 3 equations of motion, all those equations of motion can be written in the component form. Like first equation I am taking by the definition of acceleration, then V it is equals to V naught plus AT. Of course, V naught is the initial velocity, A is the uniform acceleration, T is the time. Then I can write it in the component form, that is Vx it is equals to V naught x plus Axt. Vy can be written as V naught y plus Ay t. Similarly, for the second equation with you is R equals to R naught plus V naught t plus half AT square, which you call it as equals to S equals to UT plus half AT square. If I am willing to write in terms of the displacement vector, then R minus R dash is the displacement. So I can write it as R equals to R naught plus V naught t plus half AT square. So if I am willing to write in the component form, this can be written as x naught plus V naught xt plus half Axt square, and y can be written as y naught plus V naught yt plus half Ayt square. And similarly, if you want to write the third equation, that is v square minus u square equals to 2ax. Now in place of s, we are writing the displacement vector, that is r minus r naught. So you can write this equation also in the component form. So all the equations you should be able to write in the component form for the motion when the body is moving with constant acceleration. So all these 3 equations are very important. You should be able to write in the component form all the equations. Projectile motion, whenever we are throwing any object, any particular direction we throw, but the condition is that the body is made to fall under the effect of gravity only. It means we are not using any fuel. We are simply throwing a ball, we are a stone or any other object, like you can throw your piece of chalk, whatever. So when such a body which is falling under the effect of gravity after being thrown, that is known as projectile. So projectile is any object that is in flight after being thrown in a particular direction, and it is made to fall under the effect of gravity. Of course, we are not using any fuel to make it move. Fine. So only it is under the gravity it moves. So in this study we are assuming that the air resistance is negligible and acceleration due to gravity, though we will discuss in the chapter of gravitation that it changes with the height and all the things, but here because that much height we will not be using, so in the day-to-day life, so we are taking acceleration due to gravity as constant over the entire path of the projectile. So whenever we have to study the projectile motion, the principle you may say that when we want to understand the projectile motion, we will be taking simultaneously both the components, one along the x-axis and other along the y-axis. So the component which is along the x-axis horizontal direction, that is of course is not having any acceleration, but along the vertical direction the constant acceleration is there, that is acceleration due to gravity. So this is our understanding of the for the motion of the projectile. Of course, the object which is thrown is known as projectile, and the motion of this body which is falling under the effect of gravity is known as projectile motion. So these two definitions should be clear. What do you mean by projectile and what do you mean by projectile motion? Assumptions we are doing, of course, we are assuming no resistance is there on the projectile, no air resistance, and we are ignoring the effect due to curvature of earth, we are ignoring the effect due to rotation of earth, and we are assuming that for all the path of trajectory is the path which is followed by the projectile, acceleration of the gravity, acceleration due to gravity is constant in both magnitude as well as direction. It means direction we are taking, it is acting vertically, and magnitude we are taking 9.8 meter per second square. So these are the assumptions which we should keep it in our mind for studying the projectile motion. When we talk about the projectile, then I can make the body to throw with some angle, or I can throw horizontally like this as shown in the diagram. So if you are throwing with some angle, that is known as a projectile with angular projection, or simply we may call it as oblique projectile. But if you are throwing from a height without giving any angle, simply like this, so that is known as horizontal projectile. So it means I have to study in detail about both the projectiles. One is the oblique projectile, or the projectile thrown or body thrown with some angular projection. It means some angle is being made with the horizontal line. That angle can be of course calculated or can be given in the question as per the requirement. And the track which is followed by the projectile, that is known as trajectory. So trajectory, it is simply the path which is followed by the projectile. And you can see if I throw it like this or I throw it like this, both the ways it is coming parabolic. And if I want to find the position at any point, I have to have both the coordinates with me. Whatever directions I am taking, x, y or y, z, accordingly I can have the position at any instant of time. So two types of projectiles we have to study in detail. One definition you have to note, that is what do you mean by trajectory. Trajectory is simply the path followed by the projectile. Few more definitions also you should keep it in your mind. One is point of projection, from where you project the object, that is a point of projection. Then angle of projection, that is the angle between the horizontal direction and the direction of projection. So if this is the line, horizontal line, and you are throwing like this, then theta can be calculated. Velocity is of course the initial velocity with which you are projecting, can be considered as v0 or you can call it as u. It is totally your choice. that is the initial velocity, is known as velocity of projection. Horizontal range, that is the distance which is covered in the horizontal direction by the projectile, it means along the x-axis, that is known as the r. And time for flight is simply the time during which the body is in flight, that is known as time of flight. So these are the definitions which you should have in your mind while doing the detailed study of the projectile. We are dealing with the oblique projectile motion. It means I am making the body to throw with some angle with the horizontal direction. This I have taken it as x-axis, this is y-axis. Now if I am making the body to throw like this, when initial velocity is taken as v naught, which is making an angle theta with the x-axis. This you should be noting, that v naught is making an angle theta with the x-axis. Then if I want to resolve v naught into the component form, because theta is here, so along this side you will be getting cos component, and perpendicular to it you will be getting sine component. So horizontal component, that is vx, you can say it is equals to v naught cos theta naught. If I have taken angle as theta naught, if you take simply theta, you can simply write v naught cos theta. Similarly, vertical component for velocity will be equals to v naught sine theta naught. This is vy. This is vx. So you should be able to write vx naught and vy naught initial position. And of course, if you want to see the acceleration along the x-axis, as I have already said, we are taking it equals to 0. And because you are throwing it like this against the gravity, we are taking ay equals to minus of g. Displacement along the x-axis, from the second equation you can write s equals to ut plus half at square. So for x direction you will be writing x equals to v naught xt plus half ax t square, but ax is 0. So ax component I need not write. I will be simply writing x equals to v naught xt. V naught x, it is equals to v naught cos theta naught. So it is to be multiplied with t. So you can get the value of t at any instant. It will be equals to x divided by v naught cos theta naught. And similarly, if you want to write for the y direction, then again you will be writing y equals to v by t plus ay half a by t square. So ay it is equals to minus g. So you can put the value, and you can further solve it. Sin theta upon cos theta is tan theta. So you can write it as, in terms of tan theta, you can write that is y equals to tan theta, simply by putting the value of t from first equation into the second equation. Take the value of t from the first equation, you put it in the second equation, and then you work it out. Sin upon cos is tan theta. So you can write y, it is coming out to be tan x, tan theta naught x minus g upon 2 v naught cos theta naught whole square into x square. So I can write it as y equals to ax minus bx square, where a is tan theta naught and b is this value, which whatever there is in the bracket. So this is the value of b we are considering. Simply to write it in the equation form, that is y equals to ax minus bx square. This is the equation of a parabola. This question can be asked that you derive the expression for the trajectory of the oblique projectile, or simply they may ask you to prove that path of the projectile is parabola. Then these steps you have to take, and steps are simple. Simply you write the equation along the x-axis using the second equation of motion. Write the equation along the y-axis. Take the value of t from the x-axis equation, put it in the y-axis. You will be getting t will get eliminated, and you can write y in terms of x. So y in terms of x, I am getting y equals to ax minus bx square. This is the equation of parabola, And this is the proof for the path of the projectile. Of course, the oblique projectile here we have taken is parabolic, or they may say projectile with an angular projection. And they may give you the value here in place of theta, they may give you alpha, beta, whatever value they may ask you in the question, and then you are supposed to write the steps as per the requirement. So this is very important. Direct derivation can be asked for 2 or 3 marks. They may include the question, define the projectile, oblique projectile, and then hence derive the expression for the path of the projectile, or prove that the path of the projectile is parabolic. I want to find the time which is required to reach the maximum height. If I am making the body to throw like this, as you can see, velocity at different instants is changing. At the highest point, if you see, the vertical component of the velocity will be 0. All the velocity is there which is acting in the only in the horizontal direction, and this theta will be, this value Vy becomes 0, Vx equals to V naught cos theta naught. It remains the same. So if I want to find the time to reach this position, Vy equals to 0, then you can use the first equation, that is Vy equals to Uy plus At, and Uy, initial velocity along the y direction, is V naught sine theta naught, and Ay is your g minus g. You can put the value. So you can get the value for the time which is for reaching the maximum height. It is coming out to be V naught sine theta naught divided by g. And if I want to find the total time reaching the ground, then this is double of this time. This time may be termed as time of ascent, and the time which is used to fall back, that is time of descent. And it can be proved that time of ascent, it is equals to time of descent. So total time during which the body is in flight is twice of the time which it is taking to reach the maximum height. Or you can directly prove it by using the second equation of motion, that is equals to S equals to ut plus half at square, and here y component you will be writing y equals to uyt plus half ayt square, and value of ay we have already discussed, that is equals to minus g, and initial velocity along the y direction is v naught sine theta naught. So you can put the value and you can get it directly. Total time for the flight, it is equals to 2 times v naught sine theta naught divided by g, which is double of the time of the ascent. That further proves that time of ascent, it is equals to time of descent. So whatever time the body is taking to reach the maximum height, same time it will be taking to come back to the ground. Again, this is important. These derivations directly can be asked from you, that find the expression for the time of flight for the projectile. So the things are simple, but only thing is you should be able to write the equations of motion in the component form. Once you have written it in the component form and you are knowing the values for the initial velocity along the x-axis, initial velocity along the y-axis, then you people can write these equations very comfortably. I want to write the equation for the maximum height of the projectile. For this, you may either use the second equation of motion or you can use the third equation of motion. It is your choice. When it is reaching the maximum height, it means y value, it is equals to h maximum. And this is uy, initial velocity along the y direction, v naught sine theta naught. Value of t, again we have calculated, that is time to reach the maximum height, that is v naught sine theta naught upon g. This is time to reach the maximum height, we have just calculated. Minus half g and t square, again the same value of t you will be putting, and you solve it, you are getting v naught square sine square theta naught divided by 2g. This is the expression for the maximum height of a projectile. Or you can get the same expression if you want to work with the third equation. Then you have to simply write Vy equals to 0. At the maximum height, vertical component of velocity will be 0. So that knowledge you have to use, and you can do it by using the third equation of motion also. Now the next thing is you have to find the horizontal range. It means you are throwing the body from here with some velocity, it is reaching here. So this is the horizontal distance which is traveled by the body along the horizontal direction. If I change the angle of projection, of course the horizontal range, it also changes. Horizontal range, as I have defined earlier, it is the distance traveled by the projectile along the horizontal direction. And of course, you can see that the maximum height also changes with the change in angle of projection. It means when this is with green color, this is the maximum. At this position, the body is at the maximum height. If you are throwing with this angle, then this is the maximum height. So for the maximum height also, there can be different values can be calculated. This time we have to simply find the expression for the horizontal range. And horizontal range, it means in this direction the body is traveling for the time of flight, and the component of the velocity is ux naught, you may say, which is the value is v naught cos theta naught along the x-axis. This is the velocity, and time is the total time of flight. So total time of flight, because we have calculated, you can put the value for the total time of flight in this expression, and you can get the value of r, which is equals to v naught cos theta naught into 2 v naught sin theta naught divided by g. And you all know that 2 sin theta cos theta, it is equals to sin 2 theta. So you can write this result as r equals to v naught square sin 2 theta naught divided by g. This is the final result with you for the horizontal range. And of course you can see that this range will be maximum for a particular angle if I have this sine value equals to the maximum value, and sine maximum is equals to 1. So it means sine 2 theta naught should be equals to 1. Then this range, which will become equals to v naught square by g, that will be the maximum value. And if sine 2 theta naught equals to 1, it means it is equals to sine 90. So theta naught should be 45 degree. So if I make the body to project at an angle of 45 degree, then the body is reaching, having the maximum horizontal range. This horizontal range means the distance traveled along the horizontal direction by the projectile will be maximum, and the maximum value is v naught square upon g. This is the maximum value of the horizontal range, which is there when theta is, or the angle of projection is 45 degree. Now here of course they can ask, this angle we are always taking with the horizontal direction. For these all derivations, they may ask you to find if this theta is given with the vertical direction. Then of course cos component will go along this direction, sine will come along this direction. But for the horizontal range, it will not affect for the maximum value we are taking. It will remain the same whether you measure from the vertical direction or you measure from the horizontal direction. But for other things, it may give you the different values, so that you are supposed to work at your own level. If the angle is given with the vertical direction, you should be able to work. Now you can see that what are the angles of projection for which the horizontal range comes out to be same. That is, like I have said, 45 degree. If I am throwing, then it will be the maximum value is coming out to be same whether I throw it from the horizontal direction or I throw it from the vertical direction. If you take angles for sine 45 plus or 45 minus alpha, then 2 theta naught will become the same value. So it means your horizontal range will be the same. Similarly, if you are throwing with theta naught and 90 minus theta naught, again the value of the horizontal ranges, they comes out to be same. So you can be asked with this question that for what angles of projection the horizontal range, it comes out to be the same. So that can also be one of the question with you. So of course you can always prove it by using this formula of the horizontal range. Put the value like 45 plus alpha you put in place of theta naught, or you put 45 minus alpha in place of theta naught, you will be getting the value as same, because sine of 90 plus theta is equals to sine of 90 minus theta. And similarly here also, if you put the angles theta naught or 90 minus theta naught, again you get the value same. That you can prove it yourself. So you should be able to work out with the things. If I want to find the velocity at any instant, as we have discussed the expression for the velocity. So supposingly I want to find here at this position where I am putting the cursor. So v is the velocity at this instant. So I can resolve it into components, that is v naught cos theta 1 or whatever time you may give, and this will be the vertical component, and the values for the horizontal and vertical components can be written by using the first equation of motion, v equals to u plus at. And for the horizontal component, ax is 0, so v naught x, it is here it is equals to v naught cos vx, you will write vx, it is equals to v naught cos theta naught, which means horizontal components remains the same, while vy, it is equals to initial velocity v naught sin theta naught minus gt, and the magnitude of the velocity is given by v equals to square root of vx square plus vy square. So you put the value of vx and vy, you are getting this result, that is v at any instant of time is v naught square cos square theta naught plus v naught square sin theta naught minus gt whole square. And if you want to write the angle, again vy divided by vx, so you put the value of vy and vx, and you can find the angle beta. Here this beta always we try to take with the horizontal direction. This is the beta. So you can find the value of the direction also. You can always write it in terms of tan inverse. The point which is to be noted is that the horizontal component of the velocity always remains constant throughout the motion of the body, but the vertical component is becoming 0 at the maximum height, and here at the point of reaching the ground you can prove it becomes same as with which it was started. Like initially it was v naught sin theta naught, on reaching the ground also it comes with the same velocity, that is v naught sin theta naught, but sign negative. Direction has been changed. Earlier you were throwing it in the upward direction, now it is coming in the downward direction. So this also can be proved simply by using all these three equations of motion which we have discussed for the constant acceleration. So keep things up to this. Thank you everyone.